Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a tool for you to practice for your entrance exam question papers. Here you will find a number of papers with their detailed solutions and PDF. You can also download our app. The link is available in the description box. So let's start with today's paper. Today we'll be solving VITEE 2023 paper. We'll be doing the mathematical part of this paper in this video. So let's start with the first question. That is question number 71, because mathematics questions start from here. So very first question, number 71. The argument of the complex number iota upon 2 minus 2 upon iota is equal to. So let's write it as you can write it as iota upon 2 minus 2 iota upon I square, right? I can do this. You know, iota square is equal to minus 1. So this becomes iota upon 2 plus 2 iota, right? This is equal to 5 iota by 2. That's it. So you have to find the argument of this complex number. So argument of this complex number is equal to tangent inverse B upon A. So here, you see, this is of the form A plus IB. A is equal to 0 and B is equal to 5 by 2. So that is equal to infinity, and that is for tangent of pi by 2. Okay, that means okay, I'll write tangent over here. So this is equal to tangent of pi by 2. That means this given argument is equal to pi by 2, or option D. Hope you understood this. Next is question number 72. The lines p into p square plus 1x minus y plus q is equal to 0. And this line are perpendicular to a common line for exactly one value of p, exactly two values, more than two values, or no value of p. Fine. So one thing, if these two lines, they are perpendicular to each other, then, they are perpendicular to a common line, then they must be parallel to each other. See, this is perpendicular to this line. And when this is perpendicular to this line, so which surely means that this and this, these two lines, they are parallel to each other, right? So if they are parallel to each other, what is the concept? Slope of line 1 will be equal to slope of line 2. That means these two lines, they have the same slope, right? Now let's write them in the, let's find out the slope of the line. So here is line 1. The equation is given by p into p square plus 1 x minus y plus q is equal to 0. And the line L2 is given by p square plus 1 x p square plus 1 y plus 2q is equal to 0. Here the slope will be given by y is equal to p into p square plus 1 into x plus q. And here it is given by y is equal to minus p square plus 1 upon p square plus 1 x minus 2q, which is equal to minus x minus 2q. So here the slope m1 is given by p into p square plus 1. And here the slope m2 is equal to minus 1, the coefficient of x, right? Now, sorry, according to the question, the slopes are equal. So therefore you have p square plus 1 into p is equal to minus 1, or you have p cube There's a small mistake. I forgot to write this square over here. So this is square. This is also square. So it will be question number 72. If the lines p into p square plus 1 into x minus y plus q is equal to 0, and this is equal to 0, they are perpendicular to a common line. Now, this line is perpendicular. This line is perpendicular to this line, right? Even this is perpendicular to the same line. Both are perpendicular to the same line, which surely means that these two lines are parallel. Then only they are perpendicular to a common line. Now the first line, if they if they are parallel to each other, that means surely the slope of line 1 is equal to slope of line 2. Right. So let's pick up the first line, which is given by p into p square plus 1 into x minus y plus q is equal to 0. And the line L2 is given by p square plus 1 into x. This is at the square plus p square plus 1 y to q is equal to 0. This can be written as y is equal to p into p square plus 1 x plus q. Here you can write down p square plus 1 y is equal to minus p square plus 1 square upon into x minus 2q, or y is equal to minus p square plus 1 square upon p square plus 1 minus 2q upon p square plus 1. Here the slope is given by the coefficient of x, that is equal to p into p square plus 1. Here the slope is given by minus, see, this will cancel. This will cancel 1, so minus p square plus 1. Now, according to the question, both the slopes, because the lines are parallel to each other, the slopes are equal. So p into p square plus 1 is equal to minus p square plus 1. Or you can have plus p square plus 1 is equal to 0. I'll have p square plus 1 into p plus 1 is equal to 0. See, p square plus 1 cannot be equal to 0. That means for sure you have p plus 1 is equal to 0 or p is equal to minus 1. Therefore, exactly one value of p that is equal to minus 1 is the answer. Option A. Hope you understood this. Next is question number 73. Probability that a card drawn from a pack of 52 cards will be a diamond or a king is given by. Fine. You know how many diamonds are there? There are 13 diamonds. And if I exclude one king from here, apart from the one king which you have taken for the diamond, there will be 3 more kings. Right? Actually, there are 4 kings, but one king of diamond is already counted over here. So I am taking the rest of the kings as 3 kings. Now, the required probability. See, the probability of, I'll say probability of getting a diamond card is given by 13 of 52. And the probability of getting a king is 3 upon 52. Right? So the required probability is 13 upon 52 plus 3 upon 52, which is 20. This is 16 upon 52, or you have 4 upon 13 as the answer. So you have option C as the answer to the question. Hope you got that. Next is question number 74. If n a is equal to 4 and b is equal to 7, then the difference between maximum and minimum value of n a union b is. Okay. See, first, when you are having that number of a union b, this is minimum. When a is a subset of proper subset of b, right? Now, in this case, what will be A union B? It will be B only. Hence, minimum value of n A union B will be nothing but NB, which is given to you as 7 in the question. Done. Now, this is for the minimum. When this will be maximum. When they are different, exactly different, when A and B are disjoint. Therefore, maximum value of n A union B in this case will be NA plus NB, which is 4 plus 7, that is equal to 11. And you have to find the difference between the two. Required difference is 4. Okay, so that's it. 4 is the correct answer, option D. Hope you got that. Next is question number 75. Domain of the function fx is equal to 1 upon root of 9 minus x square is. We have to find the domain. This is the given function. So clearly one thing is this, that 9 minus x square. First of all, this should be positive, greater than 0, right? And it cannot be 0, right? And it cannot be 0. So simply it is greater than 0. Correct. So 9 minus x square should be greater than 0, or x square minus 9 should be less than 3. The two factors will be x plus 3 into x minus 3 is less than 0. So domain of fx is x will belong to minus 3 to 3, right? So you have option B as the answer. Hope you got that. Next is question number 76. Sin x plus cos x is equal to 1 by 5. Tangent of 2x is equal to. Okay. You have sin x plus cos x is equal to 1 by 5. Let's do squaring on both the sides. So this, you have sin square x cos square x plus 2 sin x cos x is 1 by 25, or 2. This can be written as sin 2x is equal to, this is equal to 1, right? This 1 by 25 minus 1, or this is equal to minus 24 upon 25. Right. If you got this value, what will be the value of cos 2x? It will be given by root of 1 minus sin square 2x, because you know sin square x plus cos square x is equal to 1. Or you have cos square 2x is equal to 1 minus of 24 upon this. This is gonna give you 24 square was 576. So 620, I'll write here. 625 minus 576 upon 25. That's equal to 49 upon 25, or this is equal to 7 upon 5. Okay, now cos x is equal to plus minus 7 upon 5. See, sin x is equal to minus this 24 upon 25. Question number 76, if sin x plus cos x is equal to 1 by 5, then what is the value of tangent of 2x? Let's start with this. You are given sin x plus cos x is equal to 1 by 5. Let's do squaring on both the sides. You have sin square x plus cos square x plus 2 sin x cos x is equal to 1 upon 25, or you have this as, say, this is equal to sin 2x and this is equal to 1. So sin 2x is equal to 1 upon 25 minus 1, which is equal to minus 24 upon 25. Let's find the value of cos 2x. This will be the root of 1 minus sin square 2x, that is equal to 1 minus 24 upon 25 square. That is equal to 625 minus 576 upon 625. That gives you root of 49 upon 265. That is equal to plus minus 7 upon 25. Right. Now cos 2x can have two values. That is this and sorry. cos x can have this value, or cos x 2x can have minus 7 to pi 25. Now, what is the value of tangent 2x? That is given by sin x upon cos 2x, and again tangent 2x is sin 2x upon cos, and this was equal to minus 24 upon 25 and 7 upon 25. This is equal to 20 minus 24 upon 25 upon minus 7 upon 25. That gives you the value of tangent x as minus 24 upon 7 tangent to x, and here tangent to x will be equal to 24 upon 7. So these are the two possible values. See, either what the thing is that this angle is lying between the third and the fourth quadrant. So if the cos is positive, tan will be negative, or if the cos is negative, tangent will be positive. Okay, so now let's check which is, you don't have the negative value in the options, but I surely have 24 upon 7. That is this value. Okay, this is not in the options. So that's it. We got our answer, option D. Hope you understood this. Let's move to the next question, number 77. For a binary operation asterisk defined on from all the real numbers except 1, such that this is equal to a upon b plus 1 is non-associative, commutative, non-commutative, both a and b. Okay. So first of all, let's check it for commutator. A asterisk b is equal to this. If it is commutative, then b asterisk a should be equal to this. Right? Now, see, these two are entirely different. Therefore, a asterisk b is not equal to b asterisk a. That means it is not commutative. Right? Let's check it for the associative. So if I have something associative, you know, that's for 3 variables. So a into b into c, this is equal to a upon b plus 1 asterisk c. That is equal to a upon b plus 1 whole divided by a upon b plus 1 whole divided by c plus 1. So this can be written as a upon b plus 1 into c plus 1. Right? See, what I did over this step is now I'm taking this as the first variable and this as the second variable using this same formula. It will be first variable divided by the second variable plus 1. Okay. Now, if it is commutative, then a asterisk b in brackets asterisk c, this can be written as a asterisk b asterisk c. So now this will become a upon this into b upon this. So that is equal to a upon b c plus 1 plus 1, which is equal to a c plus 1 upon b plus c plus 1. So clearly again, these two are not equal. A asterisk b asterisk c is not equal to a asterisk b asterisk c. That means it's not associative as well, not associative as well. That means it's not associative, not commutative, both A and B. Option D is the correct answer. Hope you understood this. Next is question number 78. Cos inverse of 1 by 2 plus sine inverse of 1 plus tangent inverse of this is equal to, see, this is pretty easy question. You know, cos inverse of this, cos inverse 1 by 2 plus sine inverse 1 tangent inverse this. Cos inverse 1 by 2 is the value for pi by 3. This is the value. Sine inverse 1 is at pi by 2 and tangent inverse 1 by 3 is at pi by 6. So let's take the LCM. This will be 2 pi plus 3 pi plus pi. That is equal to 6 pi upon pi, 6. That is equal to pi. Option A is the answer. Hope you got that. Next is question number 79. If A is given by this matrix, B is given by this, and A plus B whole square is equal to A squared plus B squared, then what is the value of X plus Y? Okay, so you are given that this is A and B. Okay, so let's go for A plus B whole square. First of all, let's find out A plus B. That is equal to 1 plus X. That gives you 1 plus X. Question number 79. If A is given by this matrix, B is given by this matrix, and A plus B whole square is equal to A square plus B square, then what is the value of X plus Y? So you are given A plus B whole square. What is the formula for this? This is equal to A square plus AB plus B square plus BA, right? And that's equal to A square plus B square plus this. Now, in the question, it is given that this is equal to A square plus B square. That means that is equal to 0. AB plus B is equal to 0. AB is 1 minus 1, 2 minus 1. B is x1, y minus 1 plus B, A, that is 0. So let's do the multiplication. You have x minus y 2, 2x minus y 3 plus x plus 2, x minus 1, y minus 2 minus y plus 1 is equal to 0, can be written as 0 matrix, null matrix. This gives you, let's add them. You will have 2x minus y plus 2 or x plus 1. This will be 2x minus 2 and minus y plus 4 is equal to 0, 0, 0, 0, or 2x minus y plus 2 is equal to 0. And you have 8. This is, sorry, this is minus x over here. Okay. And this is minus x. So you have minus x plus 1 is equal to 0, which gives you minus x is equal to 1. This gives you x is equal to 1. And from here, this is the equation number 1, 2. From the third one, you have minus 2x minus 2 is equal to 0, which surely gives you x is equal to 1 again. That's it. And minus y plus 4 is equal to 0. That gives you y is equal to 4. So that is the value of x, and y you had to find out x plus y. That's 5. You have option D as your answer. Hope you got that. Next is question number 80. The value of minus a square AB AC AB minus b square BC AC BC minus c square is. You have to find the determinant of it. I'll start with this only. So let's perform some operations first. Let's take A, B, C common from R2, R1, R1, R2, and R3. Taking A, B, C common from R1, R2, and R3 respectively. What you get over here is minus A, B, C. I'm taking A outside B, C. And here you have A minus B, C. Here you have A, B, and minus C. Okay. Now again, I'm taking A, B, C common, but now from the columns. Taking A, B, C common from column 1, 2, and 3 respectively. You will have here A square, B square, C square. Determinant of minus 1, 1, 1, 1 minus 1, 1, 1, 1 minus 1. Now it's pretty easy to solve, right? So I'll apply some more operations because we are having some non-zero terms. I want to have the zero terms in this determinant so that it will be easy. Let's perform some operations. That is C2 as C2 plus 1 and C3 as C3 plus C1. So this will become a square, b square, c square. And this will be minus 1, 1, 1. This will be 0 and 0 and 2 and 0 to 0. Okay. Now, this can be written as a square, b square, c square. That is, see, you will be left with after cancelling these ones. So you will have minus 1. This minus 1 will come outside and you have 0, 2, 2, 0. Okay. So this is minus a square, b square, c square into 0 minus of 4. That is equal to 4a square, b square and c square. This is the answer to the question. Option C is the correct answer. Hope you understood this. Next is question number 81. If A is given by this matrix, then adjoint of A is equal to. Fine. So you are given that A is alpha, beta, gamma, and alpha, right? Okay. So C11, it will be given by C11, that is column 1, 1. This is given by delta. See over here, this is supposed to be delta. Question number 81, if A is equal to alpha, beta, gamma, and here is delta, then adjoint of A is equal to. All right, so you are given, this is the matrix, alpha, beta, gamma, and delta. Let's find out the cofactors, C1, 1, 1, 2. So first row, first column, first row, second column, second row, first column, and second row, second column. So this is given by delta. C1, 2 is minus 1 raised to power 1 plus 2. Here is minus 1 raised to power 1 plus 1 into first row, second column. Okay, sorry, this is gamma. Okay, so this is again minus 1 raised to power 2 plus 1 whole raised to power. This is a second row, first column. And here is beta. And here is minus 1 raised to power 2 plus 2 into alpha. So what does this matrix become? C11 is delta. Then you have minus gamma. Then you have minus beta. And then you have alpha. Adjoint of A is given by the transpose of it. So its transpose is equal to delta minus gamma minus beta and alpha. So this is the answer to the question. Let's check. You have option B is the answer. Hope you got that. Next is question number 82. If secant of x minus y upon x plus y is equal to a, then what is the value of dy by dx? Okay, secant x minus y upon x plus y is equal to a. That makes x minus y upon x plus y is equal to secant inverse of a, right? Now let's differentiate on both the sides because this is a constant. So differentiating on both the sides, you have, it will be denominator square plus into denominator, derivative of the numerator. That gives you 1 minus dy by dx minus numerator into derivative of denominator, this. So secant inverse A is a constant, so the derivative is equal to 0. This makes x plus y minus x into dy upon dx minus y into dy upon dx minus x minus y plus x into dy by dx minus y into dy by dx whole divided by, see, this will be cross multiplied, so that is equal to 0 itself. Okay. Here you have x plus y minus x into dy by dx minus y into dy by dx is minus x plus y minus x into dy by dx plus y into dy by dx is equal to 0. They will cancel and this will cancel, x will cancel, and you will have 2y is equal to minus 2. This will be 2x dy by dx. Okay. Or you have dy by dx is equal to y upon x. This is what you needed to find out, right? The value of dy by dx, that is equal to y upon x. Option D is the answer. Hope you got that. Next is 83rd question. The number of non-zero terms in the expansion of this term, this expression is. All right. So this is the given expression. 1 plus 3 root 2x raised to power 9 plus 1 minus 3 root 2x raised to power 9. Now 1 plus 3 root 2x raised to power 9 will be given by 9c0 plus 9c1 into 3 root 2x, 9c2, 3 root 2x square, 9c3, 3 root 2x raised to power 3, and so on. Similarly, 1 minus 3 root 2x raised to power 9 will be given by 9c0 minus 9c1, 3 root 2x plus 9c2, 3 root 2x square, 9c3, 3 root 2x raised to power 3, and so on. Okay. When you will add both of them, what will happen? This will cancel with this. And there is a mistake. Here is a minus, because this is odd power, and the minus will be minus raised to power minus 1 raised to power 3 will be minus 3, minus only. Okay. So these two will also get cancelled. And when you will add both of them, that is 1 plus 3 root 2x raised to power 9 plus 1 minus 3, this is equal to, it will be twice 9c0, that is equal to 1 plus 9c2, 3 raised to power 3 root 2x raised to power 2 plus 9c4, 3 root 2 raised to power 4, 9c6, 3 root 2x raised to power 6, and this will go on till 9c8, because see, 9, you can't go beyond that, into 3 raised to power 2 x whole raised to power 8. Now, the number of non-zero terms over here is 1, 2, 3, 4, 5. So there are total 5 number of non-zero terms. That is option D is the answer. Hope you got that. Next is question number 84. If a raised to power n plus b raised to power n upon a raised to power n minus 1 upon b raised to power n minus 1 is the am between this, a and b, then what is the value of n? Okay. Let's talk about the general formula. Am between, if I'm taking x and y, okay, a and b is given to you. Between a and b is equal to this, right? You are given a raised to power n, b raised to power n whole divided by this, plus this is equal to the am between them, that is, this is equal to a plus b upon 2. Let's do the cross multiplication. You have 2a raised to power n, 2b raised to power n is equal to a plus b into a raised to power n minus 1, b raised to power n minus 1. So this is 2a raised to power n, 2b raised to power n is equal to a multiplied by this, it will be a raised to power n plus a into b raised to power n minus 1 plus b into a raised to power n minus 1, b into b raised to power n minus 1 will be equal to b raised to power n only. Okay. So now this will give you, all right. So now this will give you a raised to power n plus b raised to power n minus a, b, this, minus a raised to power n minus 1 into b is equal to 0. I hope you got this. So now I'll be taking a raised to power n minus 1 common from these two terms. So here you will have a minus b, and I will take b raised to power n minus 1 common from here. And this will be equal to b minus a. That's equal to 0. Or I can write it like a raised to power n minus 1, a minus b raised to power n minus 1, a minus b. So now I'll take a minus b common from them, and you have this thing. Okay, fine. So that means either what you had to find out in the question was what is the value of n. So that means a raised to power n minus 1 minus b raised to power n minus 1 is equal to 0, or a raised to power n minus 1 is equal to this, or when the powers are same, it will be like this. Can written be like this. Okay, so anything raised, this is equal to a upon b raised to power 0. This gives me n minus 1 is equal to 0, or n is equal to 1. So that is the value of the n. Option A is the correct answer. Hope you understood this. Let's move to the next question then. 85. So the sum of this series is equal to what? Up to 15 terms. All right. So here you have, see, this series, the nth term. Nth term will be given by 1 upon n plus root of n plus 1. Correct? That means 15th term will be given by 1 upon 15 plus root of 16. Correct? Now the given series up to 15 terms will look like 1 plus root 2 plus 1 upon root 2 plus root 3 plus this, so on upon this. Okay. Now this can again be written as this is equal to, let's rationalize it, all the terms. Okay. So into root 2 minus root 3 upon root 2 minus root 3, so on till 1 upon 15 root 16 multiply 15 minus root 16, 15 minus root 16. So that is equal to 1 minus 2 upon 1 square minus root of 2 square, that is 1 minus 2, or this is equal to minus 1. It was root 2 plus 2 root 2 minus root 3 whole divided by same thing, root 2 square minus root 3 square, which is equal to minus 1, plus root 3 minus root 4 upon minus 1, so on till root of 15 root of 15 minus root of 16 upon minus 1, right? So we got this answer by you rationalizing it. So now this will become minus 1 plus 2 minus root 2, sorry, minus 1 plus root 2 minus root 2 plus root 3 minus root 3 plus root 4, so on, minus 15 root plus root 16. So they will cancel. It will keep on cancelling, and in the end, you will have like this will cancel with the plus of root 15 over here. And in the end, you will be left with only minus 1 plus root of 16. That is minus 1 plus 4, or plus minus 4 actually. So it may have two values. That is, if I'm taking plus 4, then it is 3. If I'm taking minus 4, then it is minus 5. Okay, these are the two possible values, minus 3 and 5. Sorry, it is 3 and minus 5. Minus 5 is not in the options, but surely I have 3. So option C is the correct answer to the question. Hope you got that. Next is question number 86. The equation of the circle with this center and the radius 2 is this. Then you have to find out the value of m. Okay, here you have x square plus y square minus my is equal to 0. That means in the question, you have the h value is equal to 0. K in this question is 2, and radius is given to you as, this is hk, right? Center. H is equal to 0, K is equal to 2, and radius is given to you as 2 again. So according to this, what will be the equation of the circle? You know, it is given by x minus h square, y minus k square is equal to r square. So this becomes x square, y minus 2 square is equal to 2 square. Or x square plus y square plus 4 minus 4y is equal to 4. Or you have x square plus y square minus 4y is equal to 0. Let's compare it with the given equation. X square plus y square minus m into y is equal to 0. From here you have m as 4. That's it. You got the value of m as 4. Option C is the answer. Hope you got that. Next is 87th question, integral problem. Integral of x raised to power x into 1 plus log x into dx is equal to. Okay, so you have to find out integral x raised to power x, 1 plus log x dx. So I'll put x raised to power x is equal to some t. So that makes x into x raised to power, x raised to power x. I'm finding the derivative on the both sides with respect to x. So this is equal to x raised to power x into 1 plus log x dx is equal to dt. So now this integral becomes integral of dt, that is equal to t plus some constant. What was t equal to? This is equal to this. So you have option A as the answer. Hope you got that. Next is 88th question. Integral of limit 0 to pi by 2. Root of tan x plus root of cot x is equal to. Okay. Let's start with this. Let's say this is equal to I. So integral 0 to pi by 2. This is given by sin x upon cos x plus root of cos x into sin x dx. Or this can be written as the integral of root sin x upon root cos x root upon sin x root dx, limit 0 to pi by 2. So I'm taking the LCM, that is sin x cos x integral 0 to pi by 2. So this will be equal to root of sin x into root of sin x, that's sin x, and root of cos x into root of cos x is equal to cos x dx, right? Now multiplying both the numerator and the denominator by root 2. Sorry, here is a plus between them. Whole divided by, this will be 2 sin x cos x dx, or this is equal to integral of 0 to pi by 2. This sin x plus cos x, this is root of sin 2x dx, that can be written as limit 0 to pi by 2 root 2 sin x plus cos x root of sin 2x. Now this can be written as sin 2x. See, if I'll discuss the formula for sin x minus cos x whole square, this is equal to sin square x plus cos square x minus 2 sin x cos x, or this is equal to 1 minus sin 2x. So sin 2x can be written as 1 minus sin x cos x whole square dx. Now I'll put sin x minus cos x is equal to t. Let's find the derivative, differentiating both sides with respect to x. You have cos x plus sin x dx is equal to dt. Or see, when the limits are changing from 0 to pi. So in this question, when you have put x is equal to 0, you have sin 0 minus cos 0. This is equal to minus 1. So the limits will change from minus 1. And when I put x is equal to pi by 2, you have sine pi by 2 minus cos pi by 2, which is 1. So limits will change from 0 to 1, correct? And you have root 2 because this is equal to dx, whole divided by root of 1 minus t square into, sorry, here is dt. Okay, so that is equal to root 2 will be taken outside, limits minus 1 to 1, 1 upon root of 1 minus t square dt. This is the derivative of, this is the integral of, sorry, integral of this term is equal to sine inverse t. Limits minus 1 to 1. So root 2 sine inverse 1 minus sine inverse minus 1, that is equal to root 2 sine inverse 1 is pi by 2. This is plus sine inverse 1 again. So you have pi by 2 plus pi by 2, or that is equal to pi into root 2 or root 2 into pi. Okay, let's check with the options. You have pi into root 2 or 2. Okay, this is the answer. Option B. Pi into root 2 is option B. This is the answer to the question. Hope you got that. Let's move to the next question. Question number 89. The area of the region bounded by the ellipse, this is equal to. So you are given this ellipse, it can be written as x square upon 4 square, y square upon 3 square is equal to 1. Now this given ellipse is symmetrical about both the axes. How does this look like? Let's see. So this is the given ellipse. Okay, I am not so good with making it, but okay, this is the ellipse. This is the point. Let's say this is A. This is given by 4 comma 0. And this is, let's say the point, say over here, this is B. This is given by minus 4 comma 0. Let's say this is the point C. This is given by this. And C, D. This is 0 comma minus 3. Okay, because the major and the minor x's, these are the values for that. All right. So now the given ellipse is symmetrical about both the axes and it contains only the even parts of x and y. Okay. Now I'll get back to my equation. You had the equation as x square upon 16, y square upon 9 is equal to 1. This gives me y square upon 9 is equal to 1 minus x square upon 16, or y square is equal to 9 minus 16 into 16 minus x squared, which will give you y has the values plus minus 3 by 4 root of 16 minus x squared. Now, area, because the ellipse is symmetrical, area bounded by ellipse is 4 times area of ellipse in the first quadrant. So let's find out this area, then we'll multiply it with 4 because the ellipse is symmetrical. Right, now it will be limits 0 to 4, integral limits 0 to 4, and the total area is equal to 4 times this. So 4 into integral of 0 to 4 y into dx, that is equal to 4 into integral of 0 to 4 3 by 4 root of 16 minus x square dx. This will give me 3 integral 0 to 4 this. Now, if I put x is equal to 4 sine theta, this gives me dx is equal to 4 cos theta d theta. And in this case, when x is equal to 0, theta will be 0. And when x is equal to 4, theta will be equal to pi by 2. Okay, so that's it. We got the limits. Now let's change them. So required area becomes, this is given by 4 into 3 by 4 integral of, okay, this is already done. So integral of 0 to pi by 2 root of 16 minus 16 sine square theta into 4 cos theta d theta. This makes it 3 integral 0 to pi by 2. So this 4, like 16, root 16 will be taken outside. So this is equal to this. This is 1 minus sine square theta into 4 cos theta into d theta. This is equal to 12, 0 to pi by 2. So 1 minus cos sine square theta root. This is cos theta. 4 is again taken outside. So cos square theta d theta. I hope you got this. So this is equal to 48 integral 0 to pi by 2. So cos square theta will be written as 1 plus cos 2 theta upon 2 d theta. So this will cancel. 2 will cancel from the denominator. You will have 24 from here, 0 to pi by 2. This, let's write them separately. So that is 1 into d theta plus 24 into integral of 0 to pi by 2 cos 2 theta into d theta. So this is 24 theta 0 to pi by 2 plus 24. So 1 plus cos theta upon 2, this can be written as integral will be sine 2 theta upon 2. The limits are 0 to pi by 2. So this gives me 24 pi by 2 minus 0 plus 12 sine pi minus sine 0. That is 0 and 0. So this is, that is equal to 12 pi. So the answer to the question is equal to 12 pi square units, because the area we have to find out. So 12 pi is the correct answer. Option A is the correct option. Hope you understood this. Let's move to the next question. Question number 90. If the vertex of the parabola is given by 2 minus 1, equation of the rectus is this. What is the length of latus rectum? To find out what is the formula for latus rectum, first of all, the formula is 4a. That means I need to find out a in the question, right? Now, a is given by the modulus of 2 into 4, that is 8, minus 1 into minus 3 plus 1. And 21 will be taken on this side. This will be 4x minus 3y minus 21 is equal to 0. So, minus 20 of 21 upon the root of 3 square, 4 square plus minus 3 square, which is equal to, over here, this is 3. Okay, this is minus 3 into minus 1, this is 3. So this will give you 10 minus 10 mod divided by 16 plus 9, that is equal to 25, or this is equal to 10 upon 5, or that is equal to 2. So got the value of A as 2. Latus rectum of parabola is equal to 4A, which is equal to 4 into 2, that is 8. So this is the latus rectum, option B. Hope you got that. Next question number 91. Eccentricity of this ellipse x square plus x square upon a square plus y square upon b square is equal to 1 if it passes through these 2 points is given by. Question number 91. Before starting this question, students, as a quick reminder to visit our website www.examsnet.com. There you will find similar type of multiple entrance exam question papers for your practice. You can also download our app. The link is available in the description box. So let's start with this question. Question number 91. Eccentricity of this ellipse, if it passes through these 2 points, is given by. Fine. So first of all, this is the given equation of the ellipse. If this ellipse is passing through this point, this makes it 9 square, that is 81 upon a square plus y square, which is 5 square, that is equal to 25 upon b square is equal to 1. This gives you 81 b square 25 a square is equal to a square b square. Okay. Similarly, if the point is passing through 12, 4, so this equation will give you 12 square is 144 upon a square plus 16 upon b square is equal to 1, or 144 a square plus 16, 144 b square plus 16 a square is equal to this. So from 1 and 2, both of them are equal. So from 1 and 2, you have 81b square, 25 a square is 144b square plus 16 a square, or this gives you 9a square is equal to 144 minus 81, that is 63b square, or b square upon a square is equal to 9 upon 63. That's it. And what the eccentricity is given by? Eccentricity is given by the formula 1 minus b square upon a square. So this is given by 1 minus 9 upon 63 whole under the root, that is equal to 63 minus 9 upon 63. This is 54 upon 63. So that is given by, let's say this is 9 into 6 and 9 into 7. That is 6 upon 7 under the root. So this is the answer to the question, 6 upon 7 under the root, option D. Hope you understood this. Next is question number 92. In a triangle ABC, the midpoint of these three sides are these three coordinates respectively. Then you have to find out the value of this given expression. Let's try and understand the problem through a figure. Let's make the triangle. So here is the A, and let's say this is B, and let's say this is C. So A is, let's say x1, y1, z1, x2, y2, z2, x2, y3, x3, y3, z3. So these are the three midpoints, and they are given as L, 0, 0, 0, M, 0, and 0, 0, N. Now, if they are the midpoints, now according to the question, we have so many equations over here. Let's try the first one. So if I'm talking about this midpoint, then x1 plus x2 is equal to 2L. Similarly, y1 plus y2 is equal to 0. z1, z2 is equal to 0. Also, x2, x3, 0, y2, y3 is equal to 2m, z2, z3 is equal to 0. And similarly, you have x1, x3 is equal to 0, y1, y3 is equal to 0, and z1, z3 is equal to 2n. When you will solve all these set of equations, you're going to get x1 is equal to L, x2 as L, y1 as M, and over here, x3 will be minus 1. Okay, y1 is equal to minus m, y2 will be equal to m, and y3 also m. Similarly, z1, z2, and z3. z1 is n, z2 will come out to be minus n, and z3 will be n again. Okay, so now let's make the coordinates. Coordinates for A will be L minus M, N. For B, it will be L, M minus M. C, it will be minus 1, M, and N. These are the three coordinates. Let's find out the value of AB. AB is given by distance formula. Root of L minus L, that is 0. M plus M, which is 2M square. And N, this is 2n minus 2n square. This gives you root of 4m square plus 4n square, or this is 2 root m square plus n square. This is the value for AB. Okay, now let's find out BC. BC will be given by L minus of minus L, which is equal to 2L square plus M minus M. This is 0 square. Minus N, this is minus 2N square. Again, the same thing. It will be 4L square plus N square, or this is 2 root of L square plus N square. Now let's go to find the third side, which is AC. This is given by root of L plus L. This is 2L square plus minus 2m square plus n minus n, that is equal to 0 square. So this will again be equal to root of L square plus m square. Okay, now you have to find out the value of this expression. Let's write it down. To find this, AB square, BC square, AC square whole divided by L, M, and n square. So this gives you AB square was equal to, this will be 4m square plus n square. BC square will be 4L square plus 4n square. And AC 4L square, 4m square whole divided by L square plus m square plus n square. This is gonna give you 8L square, m square, n square divided by this. So that is equal to 8. Answer to the given question is 8. Option A is the answer. Hope you understood this. Next is question number 93. If f of x is given by x plus mod of function x upon x, then the value of limit x approaching 0 f x is equal to. Fine, let's find the left hand limit of it. So this is limit h approaching 0 minus h plus mod of h upon minus h, that is equal to limit h approaching 0. This will be 0 only. Okay, because this will be 0. And the right hand limit will be limit h approaching 0 plus, here will be h plus this upon h, that will be equal to 2. So we don't have the limits as equal. LHL is not equal to RHL. Therefore, the limit does not exist. Option C is the correct answer. Hope you got that. Next is question number 94. The given expression is P is to Q is to P is given by what? Question number 94, negation of this Boolean expression is given by. So basically you have to find out negation of this Boolean expression. Now this is given by, if I talk about generally that P double implies Q, the negate of it is given by P, this conjunction negate of Q, conjunction Q. This is disconjunction negate of P. So this expression, that is this expression, will become P disconjunction negate of Q implies P, conjunction Q implies P, disconjunction negate of P, right? And if I pick up the first expression, that is P, I'll say intersection for the easier thing. This Q implies P, negate Q implies P. This is equal to, this is P intersection negate of P intersection Q, which is equal to some C. Okay. Now the second one, Q implies P intersection negate of P is equal to negate of Q union P intersection negate of P, that is equal to negate of P intersection negate of Q union P. So this is equal to negate of P intersection negate of Q union negate of P intersection P. So this is nothing, this is 0, and this will be negate of P intersection negate of Q. So our given expression, see, this was like you can say this is 1 and 2, and I have solved 1 over here and 2 over here. So I'll fill in the given equation now. So negate of P, Q implies P is equal to C union negate of P intersection negate of Q, or this is equal to negate of P intersection negate of Q. So this makes option D as the correct answer. Hope you understood this. Next is question number 95. If R is a function, R is a set such that X and Y, okay, X is exactly 7 centimeters smaller than Y. So R is defined by this function. X is exactly 7 centimeters taller than Y. Then R is equal to. See, over here, if I talk about R, first of all, R is not reflexive. Their options are symmetric, reflexive, symmetric but non-transitive, or equivalence relation. So if I'm looking at R from that point of view, so R is not reflexive, as X is not 7 centimeter taller than, as X is not 7 centimeter taller than X. Now, R is not symmetric as well. R is not symmetric as well, as if X is exactly 7 centimeter taller than Y, as if, let's write it down, X is exactly 7 centimeter taller than Y, then Y cannot be 7 centimeter taller than X. So it is not symmetric, it's not reflexive, and R is not transitive as well. As if X is exactly 7 centimeter taller than Y, and Y is exactly 7 centimeter taller than X. According to this, X will be 14 centimeter taller than X itself. Okay, so even it's not transitive. That means you have it's symmetric but not transitive. So this is wrong. Okay, it's not reflexive. It's reflexive. This is also wrong, but it is not symmetric. Option A is the correct answer. Hope you got that. So option C, it is only not symmetric. Here it is saying symmetric, which is wrong. Reflexive is wrong. It's an equivalence function, a relation, that is also wrong. That means only the option A is left. And that it's not symmetric. This is true. It is not symmetric as proved over here. So option A is the correct answer. Hope you understood this. Let's move to the next question, number 96. The particular solution of this given expression equation is equal to. So here you have dy by dx. I'm taking log to the right hand side. This will be given by e raised to power 3x plus 4y, which is given by e raised to power 3x into e raised to power 4y. This is equal to dy by dx, or you can say e raised to power minus 4y into dy is equal to e raised to power 3x into dx, right? So let's integrate on both the sides. What you will get is e raised to power minus 4y upon minus 4 is equal to e raised to power 3x plus 3. If I put x is equal to 0, then you will have this as e raised to power minus 4y upon 4 minus 0 e raised to power 0 upon 3 plus c. Or here you have, okay, one thing I missed. This is when x is equal to 0, y is also equal to 0. So this will be e raised to power 0 upon 4 is equal to 1 upon 3 plus c, or 1 upon 4 minus 1 upon 3 is equal to c. This gives me c is equal to 1 by, this is 4. Question number 96, the particular solution of log dy by dx is equal to 3x plus 4y. When y of 0 is equal to 0 is. So from here, when x is equal to 0, you have y is equal to 0. So now log of dy by dx is equal to 3x plus 4y, or dy by dx will be taken, can be written as e raised to power 3x plus 4y, which is equal to e raised to power 3x plus e raised to power 4y, or you can write it as e raised to power minus 4y into dy is equal to e raised to power 3x into dx. Let's integrate on both the sides. So you will have e raised to power minus 4y upon minus 4 is equal to e raised to power 3x upon 3 plus the c. So if I put x is equal to 0, you know y is also 0 at that point. So you have e raised to power 0 upon minus 4 is equal to e raised to power 0 upon 3 plus c. Or this is given by minus 1 by 4 minus 1 by 3 is equal to c. This gives me c's value as minus 7 by 12. Okay, now we have e raised to power minus 4y upon 4 is equal to e raised to power 3x plus this, plus c can be written as minus 7 upon 12. This is from this equation. If before integrating this equation, okay, before integrating. All right, so now this will be given by e raised to power minus 4y upon minus 4, e raised to power this upon 3 is equal to minus 7 upon 12. I'm multiplying both the sides by minus 1 at the same time. I'm taking the LCM. So this is 12. This has got to be 3 into e raised to power minus 4y plus 4 into e raised to power 3x is equal to 7 by 12. So 12 and 12 will cancel. You have 3 e raised to power minus 4y, 4 e raised to power 3x is equal to 7. So that's it. You have option D as the answer. Hope you understood this. Next is question number 97. Tan inverse x plus tan inverse y is equal to c, the general solution of the differential equation. Then which of the following is true? So you have tan inverse x plus tan inverse y is equal to c. This is the general equation, general solution of the differential equation. Okay. Which of these is true? Fine. So let's differentiate both the sides with respect to x. Both sides with respect to x, you have 1 upon 1 plus x square plus 1 upon 1 plus y square into dy by dx is equal to 0. Or you will say dx upon 1 plus x square plus dy upon 1 plus y square is equal to 0. Or with this dx plus 1 plus x square dy is equal to 0, which is option C. Hope you got that. Next is 98th question. So here we have a vector problem. If the magnitude of A vector is 3, magnitude of B vector is 4, then a value of lambda for which A plus lambda B is perpendicular to A minus lambda B is given by. Okay. So you are given that A plus lambda B is perpendicular to A minus lambda B, right? Then if they are perpendicular to each other, their dot product will be given by if they are perpendicular, then that means their dot product is 0. So let's find the dot product. A plus lambda b, A minus lambda b vector. This is, of course, given by the mod of the magnitude of A plus lambda b, A minus lambda b into cos of the angle between them, that is cos of 90 degree. So that gives you that this is equal to 0, right? Or you can write it as A dot A minus lambda A dot B plus lambda this minus lambda square B dot B is equal to 0. So, that is equal to A square minus lambda square B square, because they will cancel out each other. This is equal to 0, or lambda square is equal to A square upon B square, which gives you lambda square is equal to, see, this is the magnitude we are talking about, right? And A's magnitude was 3 and B was 4. So that is equal to 9 upon 16. That's it. That's lambda square. What do we have to find out? Lambda. All right. So lambda is equal to plus minus 3 upon 4. These are the two possible values. We don't have the negative value in the options, but surely we have the positive value in the option B. So this is the correct answer to our question. Hope you understood. Next is 99th question. The area of the parallelogram whose diagonals are given by this is. All right. So you're given the two diagonals of the parallelogram. Required area, it can be very easily formed using the determinant method. So required area will be given by I, J, K. So here is 3 by 2, 1 by 2 minus 1, then 2 minus 6 and 8. Right? Let's find the determinant. You have I cap. This is 1 by 2 into 8. That is equal to 4. Minus minus plus, and this is minus 6 again. Okay. All right. Then you have, here I forgot to write this half. Yes. So this is 1 by 2 outside. Fine. So minus j into 3 by 2 into 8, that is 3 4s are 12, minus minus plus 2 plus k. 3 by 2 into this is minus 9 minus 1. So that is going to give me this minus 2 I cap minus 14 j cap minus 10 k cap. Okay. That is minus I minus 7j minus 5k. What do you have to find out in the question? The area of the parallelogram. For that area, we need to find out. The area will be given by root of minus 1 square plus minus 7 square minus 5 square, which is 1 plus 49 plus 25, which is root of 75, or that is equal to 5 root 3 square units. So you have option A as the answer. Hope you understood this. Next is 900th question. Bag P contains 6 red, 4 blue balls, and bag Q contains 5 red and 6 blue balls. A ball is transferred from bag P to Q. Let's make it together. So here's the bag P and here is the bag Q. This is having 6 red and 4 blue balls. This is having 5 red and 6 blue balls. A ball is transferred from P to Q and then from Q to P. Okay, sorry, not transferred. A ball is transferred from P to Q and then a ball is drawn from Q. What is the probability that the ball drawn is 5? Okay, so first of all, let E1 and E2 be the two events. defined as two events which are defined as E1 is equal to red ball from P to Q. E2 is defined as blue ball from P to Q. Now, let's say A is that you are drawing a ball from Q and it is blue. Okay, that from Q, the ball drawn is blue, and see, this is what we need to find out, right? Blue. And okay, I will not go with the B thing now. So as bag B contains 6 red and 4 blue balls, right? So the probability of event 1 to happen, that is a red ball which is drawn from the first P bag. In that case, it will be 6 by 10, right? 6 upon 10, because there are total of 10 balls. That is equal to 3 by 5. And the probability that event 2 will happen, that is a blue ball is transferred from P to Q. This is this is equal to 4 upon 10, which is equal to 2 by 5. Now events E1 and E2, they are mutually exclusive. And exhaustive events, right? When E1 has occurred, that is a red ball is already transformed from bag P to Q, the bag C. In case of E1, that from P to Q, a red ball is transferred. What will the bag Q contain now? Bag Q will contain 6 red and 6 black balls, right? See, initially it had 5 red and 6 blue. So when a red ball is transferred from P to Q, now the bag Q will have 6 red and 6 blue balls. So the probability that the ball withdrawn from the Q bag is blue is given by probability of A upon E1. That is equal to 6. Yeah, how many blue balls are there in this? There are 6 blue balls. Okay, so in this case, it will be given by 6 upon 12. So that is equal to 1 by 2. And in case of E2, which means from P to Q, you have a blue ball transfer. Now the Q bag will contain 5 red and 7 blue balls, right? So probability of event A upon E2 is given by, see, now it is having 7 balls blue. So 7 upon total balls are this 12. So that is equal to 7 upon 12. Okay. So this is given by 1 by 2 and this is given by 1 by 12. Now what we had to find out, okay, the total probability. So by using law of total probability, we get PA is equal to PE1, PE2, sorry, PE1 into PA upon E1 plus PA2, PA upon E2. So that is equal to 3 by 5 into 1 by 2, 2 by 5 into 7 by 12, which is equal to 3 by 10 plus 7 upon 30. So this is equal to 16 upon 30 or 8 upon 15. So 8 upon 15 is the correct answer. Option B is the answer. Hope you got that. Let's move to the next question, number 101. The mean and variance of the random variable x having binomial distribution are 4 and 2 respectively. Then what is the value of probability when x is equal to 1? All right. So you are given that mean is 4 and variance 2. That means N into P is 4. NPQ is equal to 2, which gives me Q is equal to 2 by 4 or 1 by 2. If P is 1 by 2, then Q is 1 by 2, then P is 1 minus 1 by 2, which is equal to 1 by 2 again. Okay. And from here, if I'm filling this, N will be given by 8. Now, probability X is equal to 1 is given by 8C1 into, this is 1 into 2, that is P's value into Q raised to power N minus 1, which is 7. So this gives me 8C1, that is 8 only into 1 by 2 raised to power 8. This is 8 into 2 raised to power 3 into 2 raised to power 5. So this is equal to 1 upon 32. So you have option B as the answer. Hope you understood this. Next is 102 question. The value of tan of cos inverse 4 by 5 plus tan inverse of 2 by 3 is equal to. Okay. So see, this is, in this case, if I'm treating this as A and B, so you know one formula that tangent of A plus B is given by tangent of A plus tangent of B plus 1 plus minus tangent A into tangent B. So this is now I'm considering A and B. So this will be written as tangent A plus B. This is equal to tangent of is the correction. Here is tan inverse. Okay. So this will be tangent of tan inverse 4 by 5 plus tangent of tan inverse 2 by 3 whole divided by 1 minus tangent of tan inverse 4 by 5 tangent of tan inverse 2 by 3. So this is gonna give me 4 by 5 plus 2 by 3, 1 minus 4 by 5 into 2 by 3. Question number 1 and 2, the value of tan of cos inverse 4 by 5 plus tan inverse 2 by 3. Okay, see, if I had a tan over here, tan inverse, then the problem would have been solved easily. Let's do that thing. Let's say cos inverse 4 by 5 is equal to theta. This gives me 4 by 5 is equal to cos theta. If I draw it on the right angle triangle, you know, this is base upon hypotenuse. So if this is 4, this is 5, you know, this is 3. I don't need to calculate it. Using the Pythagoras theorem, we know this is equal to 3, right? So that gives me tangent of theta is equal to base perpendicular upon base, that is equal to 3 upon 4. So theta will be equal to tangent inverse 3 by 4. That means cos inverse 4 by 5 is equal to tangent inverse 3 by 4. So now this expression becomes tangent of tan inverse 3 by 4 plus tan inverse 3 by 3, 2 by 3. Now I'm considering this as an A and B, and you know this formula, tangent of A plus B is equal to tangent of A plus tangent of B whole divided by 1 minus tangent A into tangent B. So that is equal to tangent of tangent inverse 3 by 4 plus tangent of tangent inverse 2 by 3 whole divided by 1 minus tangent of tangent inverse 3 by 4 into tangent of tangent inverse 2 by 3. This is equal to 3 by 4 plus 2 by 3 whole divided by 1 minus 3 by 4 into 2 by 3. This gives me 12, 9 plus 8 whole divided by 1 minus 1 by 2, which is equal to 17 upon 12 divided 1 by 2. That is equal to 17 upon 6. So this is the answer to the question. Option B is the correct option. Hope you got that. Next is 103rd question. So it says, I'll write it properly. It says, if the function fx is equal to, question number 103, the function fx is equal to 1 when x is less than equal to 2. It's equal to ax plus b when x lies between 2 and 4. And it's equal to 7 when x is greater than equal to 4. Then this is continuous. This function is continuous at x is equal to 2 and x is equal to 4. Okay. Now you have to find out the values of a and b. Since the function fx is continuous at x is equal to 2, therefore, the left-hand limit will be equal to f of 2 will be equal to the right-hand limit. Let's find out. So this is the limit x approaching 2 minus. This is equal to f of, this will be 1. Okay, f of x is equal to f of 2. That's equal to limit x approaching 2 plus fx. Now this is equal to 1 for 2 minus, and that is f of 2 is equal to again 1 over here, because according to this x is equal to 2, for that value is equal to 1, and for 2 plus this is given by ax plus b. So that means you have ax plus b is equal to 1, and x is equal to 1 in this case. Sorry, x is equal to 2, so that means you have 2a plus b is equal to 1. Okay. Fine. Now you are given fx is continuous at x is equal to 4, which means left hand limit at x is equal to 4 is equal to f of 4 is equal to the right hand limit, which makes limit x approaching 4 minus fx is equal to, see, for 4 f of 4 when x is equal to 4, the value is equal to 7, and for 4 plus also this is 7. For 4 minus, it will be taken as ax plus b. Okay, so that is equal to limit x approaching 4 plus fx. Now for 4 minus, it was equal to ax plus b, that is actually a into 4 plus b. X will be put as 4. So a into 4 plus b is equal to this is equal to 7, which makes 4a plus b is equal to 7. So I have the two equations here. The equation was 2a plus b is equal to 1. Let's subtract. You have 2a is equal to 6 or a is equal to 3, which gives you a is equal to 3, and 2a plus b was equal to 1. So 6 plus b is equal to 1, which gives you b is minus 5. These are the two values for a and b. A is equal to 3 and b is equal to minus 5. Okay, you have option A as the answer. Hope you have understood this. Let's move to the next question then. Number 104, the derivative of sine inverse 2x upon 1 plus x square and with respect to cos inverse 1 minus x square upon 1 plus x square is equal to. Fine. So let's say this is equal to s, and let's say this is equal to some t. And we have to find out d s upon dt. This is what according to the question is. So let's say, let's put x is equal to tangent of theta. So we get s as sine inverse 2 tangent theta 1 plus tangent square theta, which is equal to sine inverse. This is the formula for sine 2 theta, or this is equal to 2 theta, which is equal to 2 into tan inverse of x. Okay, so now let's say you got this as s, right? ds upon dx will be given by 2 upon 1 plus x square. Similarly, you had t as cos inverse 1 minus x square, which will be written as 1 minus tan square theta upon 1 plus tan square theta, which is the formula for cos 2 theta. So cos inverse cos 2 theta, which is equal to 2 theta, or 2 into tangent inverse of x. That was equal to your t. So dt upon dx is equal to 2 upon this. You had to find out from the, let's say this is 2 and this is 1. You had to find out ds upon dt. This is given by ds upon dx upon dt upon dx. So that is equal to 2 upon this divided by this, which is nothing but 1, right? So you got your answer as option A. Simple as that. Next is question number 105. The number of distinct real roots of this equation is equal to. Okay, let's write down. You have this equation, x raised to power 7 minus 7x is equal to 2. So here fx is equal to x raised to power 7 minus 7x and y is equal to 2. So differentiating with respect to x, you will have f dash x is equal to 7 into x raised to power 6 minus 7, which is 7x raised to power 6 minus 1. This can further be split up. The two factors will be x square minus 1 and x raised to power c. You will divide x raised to power 6 minus 1 with x square minus 1. You will get the quotient as x raised to power 4 plus x square plus 1. So that's it. Okay. So now, if, okay, f of the first derivative at x is equal to 0 is, see, here is, sorry, f dash x is 0. This implies x is equal to plus minus 1. Now, the function is strictly increasing. A function is strictly increasing at question number 105. The number of distinct real roots of this equation is. So you are given, this is the equation. You can write it like this: 7x raised to power 7 minus 7x is equal to 2. So here you can consider this as fx and this as, sorry, this as the function fx and this as your y. Yeah. Okay. Now differentiating it with respect to x, you have f dash x given by 7 into x raised to power 6 minus 7, or you can say 7 will be taken outside. So you have 7x raised to power 6 minus 1, right? Fine. Now you can write it as x square minus 1 into x raised to power 4 plus x square plus 1. How is that? See, x square minus 1 is one of the factor. X raised to power 6 minus 1 when divided by x square minus 1 will give you the quotient as 1 plus x square plus x raised to power 4. Right? Now, if f dash x is equal to 0, which gives you x is equal to x square is equal to 1, or x is equal to plus minus 1. Right? Now, a function is strictly decreasing at minus 1, 1 and increasing at some points of x is less than minus 1 and x is greater than 1. So y is equal to 2 intersects this at 3 points. That means fx is equal to 2 has 3 real distinct solutions. All right. That is option 3, D. Hope you got that. Next is 106th question. The minimum value of the function y is equal to x raised to power 4 minus 2x squared plus 1 in this interval is. So you are given the function, let's say this, this is y is equal to x raised to power 4 minus 2x squared plus 1. Let's differentiate it with respect to x. You have 4x raised to power 3 minus 4x plus 0. So let's take 4x common. You have x square minus 1. Now, for minimum, or maximum value. You have this dy by dx is equal to 0, which gives you 4x, x square minus 1 is equal to 0, which simply means that either x is equal to 0 or x is equal to plus minus 1. Right. Now, both of these things, 0 and plus minus 1, they does not belong to this interval. Right. Sorry, plus minus, wait. X is equal to 0 and x is equal to minus 1. These two does not belong to 1 by 2 to 2. So simply what does that mean? X is equal to 1. So that makes you have to find the minimum value, right? Let's find out. You had the dy by dx was equal to 4x cube minus 4x. I think this was the one. Yes. So the second derivative will be equal to 12x square minus 4. And second derivative at, for the minimum value, you have to find the second derivative at the given equation, at the given x value. So this is equal to 8, which is greater than 0. So that means this is there's a minimum value of the function at x is equal to 1. Therefore, there is minimum value of function at x is equal to 1, and the minimum value is given by, minimum value for the function was equal to, given function was this, x raised to power 4 minus 2x square plus 1. So this is 1, 2 into 1 square plus 1, which is equal to 0. So this is the answer to the question, option A. Hope you understood this. Next is 107 question. Integral of sine square x minus cos square x divided by sine square x into cos square x dx is equal to. Okay, I'll split it up first. This can be written as sine square x upon sine square x cos square x dx minus integral of cos square x upon sine square x cos square x dx, that is equal to root of integral of 1 upon cos square. I can directly write it as secant square x dx, and this will be cosecant square x dx. So let's say this is equal to I. You can write it like this, secant square x minus cosecant square x dx. So let's find the root. This is secant square is the root integral of, the derivative of tan x minus of, this is for the cot x minus cot x plus the constant c. So this is the answer to the question, tan x plus cot x plus c. That's it. You have option tan x plus cot x, that is option A. Hope you understood this. Next is question number 108. You have to consider the curve y is equal to yx in the first quadrant as shown in the figure. Let area A1 is twice the area A2. So this is area A1. This is twice the area A2. Then normal to the curve perpendicular to this line does not pass through which of these points? All right. So here you are given a condition that area A1 is equal to twice area A2. Now, given the graph is a rectangle, see if we are looking at this one, this is forming a rectangle. Given the graph is a rectangle, then the required area, that is A1 plus A2 is given by x into y. See, this is x, right? Till here you have this x, this is 4, this is 2 and y. So this is equal to x into y minus 4 into 2. That is equal to x, y minus 8. Now, if I'm putting A1 as 2A2, so this is gonna give me 3A2 is equal to x, y minus 8, or A1 is equal to, I'll take it in the form of A1, that will be wait. So A1 is equal to A1 plus half of A1. This is 3 by 2 A1 is equal to xy minus 8, or A1 is equal to 2 by 3 xy minus 16 upon 3. So fx from integral from 4 to from this 4 to this x. From 4 to x, fx is equal to 2 by 3 xy minus 16 upon 3. Hope you got that. So let's take it the opposite thing. So you will have integrate in finding the derivative of both the sides. You have fx is equal to 2 by 3, differentiating both sides. 2 by 3 into first function derivative of second plus second function into derivative of first minus 0. Okay. So this gives you fx is equal to 2 by 3. First function was x. So x into dy by dx plus y. That was equal to, okay. Yeah. So this is equal to fx. This can be 2 by 3 into dy by dx. This is y upon this plus y upon 2 by 3y. So this becomes 1 by 3 into y is equal to 2 by 3 into x dy by dx. You will cancel 3 from the denominator on the both sides. You will have y is equal to 2x into dy upon dx. All right. Or you will have here, you can write it as 2 dy upon y is equal to dx upon x. Let's find out the integral. This is the integral for log. The integral is log y is equal to log x plus log c. So you have here y square is equal to c into x. Okay. Sorry, there is log c. This can be written as log of c into x. So, and this can be written as, this can be written as log y square, and this is log c into x, or y square will be equal to c into x. Now, from the given graph, you have f of 4. See, f of 4 is equal to 2, right? From graph, you have f of 4 is equal to 2, which gives you c is equal to 1 from here, right? So from this given equation, you had y square is equal to x. From this equation, now line was 2x minus 12y is equal to 15, or 12y is equal to 2x minus 15, which gives you y is equal to, wait, it was 2x minus 12y is equal to 15, yes. So which gives you this value, or this is 1 by 6x minus this. Now, this line, they are perpendicular. So slope of the normal will be given by, here the slope is 1 by 6. Slope of normal will be given by 1 minus 1 divided by 1 by 6, or that will be equal to minus 6. Therefore, you have y is equal to, in that case, let's find out y. That was equal to minus 6 into x minus 1 by 2 into minus 6 minus 1 by 4 minus 6 raised to power 3. Question number 108, consider the curve y is equal to yx in the first quadrant as shown over here. Let A1 area is twice the area A2. So this area A1, this is A1 area, this is twice the area A2. Then the normal to the curve perpendicular to this line does not pass through which of these options? Okay. So, all right. First of all, you are given that the condition that area A1 is equal to twice area A2. Now, given the graph is of the rectangular shape, see, this is a rectangular shape. So, area A1 plus A2. This area plus this area is nothing that, see, this is Y and this is X, this is 4 and 2. So that is equal to X into Y minus 4 into 2. That is X, Y minus 8. This is the area of A1 plus A2. If I write, you know from here, A1 is equal to twice A2 or A2 is equal to 1 by 2 A1. So you can write it as 1 A1 plus 1 by 2 A1 is equal to XY minus 8 or 3 by 2 A1 is equal to XY minus 8 or A1 area 1 is equal to 2 by 3 XY minus 16 by 3. So this area is equal to this much. Okay. Now let's take the integral on both the sides. The limits are from 0 to, from 4 to x. So integrating both sides, this fx from 4 to x is equal to 2 by 3 xy minus 16 upon 3. Because this area 1 is the area of this portion for 4 to x. The limits 4 to x, right? Here is dx also. Now differentiating both sides, you will get fx is equal to 2 by 3 will be taken outside. And here's first function to derivative of second plus second function into derivative of first minus 0. So this is nothing but y. This is 2 by 3 x dy by dx plus 2 by 3 y. This gives you 1 by 3 y is equal to 2 by 3 x dy by dx. This and this will get cancelled, and you will have y upon x is equal to dy upon dx, which will give you 1 upon x dx is equal to 1 upon y dy. I missed this 2. This 2 will remain on the y side. Okay, this side. Fine. It was supposed to be this side. Yeah. Okay, so now integrating both the sides, you can write it as log of x plus log of, not plus, is equal to. So this can be written as log of x plus the constant c is equal to twice log of y. Or this, I can write log of c also. The constant can be written this way also. This makes log of xc is equal to log of y square, or y square is equal to xc. Now from the graph, you have f of 4 is equal to 2. From graph, f of 4 is equal to 2, which makes this equation as 2 square, that is 4 is equal to 4 into this, with that makes c is equal to 1. So what does this equation becomes? Y square is equal to x. Now the given line was this, 2x minus 12y is equal to 15. Line 2x minus 12y is equal to 15, which gives you 12y is equal to 2x minus 15, or y is equal to 1 by 6x minus 15 by 12. Here the slope is equal to 1 by 6. So what is the slope of the perpendicular line now? Slope of perpendicular line, you know the product of two perpendicular lines, the product of slope of two perpendicular lines is equal to minus 1. So that is slope of the perpendicular line is given by 1 divided by 1, minus 1 divided by 1 by 6, that is equal to minus 6. So this is the slope of normal. Therefore, the required equation becomes y is equal to minus 6 into x minus 1 by 2 minus 6 minus 1 by 4 minus 6 whole raised to power 3. That gives you y is equal to minus 6x plus 3 plus 54, or y plus 6x is equal to 57. Now let's check with the coordinates. First one is 6, 21. Second is 8, 9. So first 6 and 21 it was. Yes. And the second one is 8, 9. So 6 plus 6 into 21 should be equal to 7. That makes 6 plus 126. This is, of course, not equal to 57. So this is wrong. Second one, 9. Sorry, I did this wrong. This is supposed to be 21 plus 6 into 6 should be equal to 57. So 21 plus 36, that is equal to 57. That is satisfying. Okay. The second one, 8 and 9. So 9 plus 6 into 8 should be equal to 57. 9 plus 48, this is 57 is equal to 57. This point is also satisfying. So the both points are satisfying this equation. Third one, 10 comma minus 4. 10 comma minus 4. The given equation of the line was equal to y plus 6x is equal to 57. Should be equal to 57. So minus 4 plus 6 into 10 should be equal to 57. But this is 56. Right? And that is not equal to 57. That means we got our point which is not satisfying this question. Option C is the correct answer. Hope you understood this. So we had to find out the normal to the curve perpendicular to this line that does not pass through the point, and it's not passing through this point. Hope you understood this. Next is 109th question. The shortest distance between these two lines is given by. So this is the line x is equal to, let's write on the two lines equations. X is equal to y plus 2 is equal to, I'll take 6 common, z minus 1. Then you can write it as x upon 6 is equal to y plus 2 upon 6 is equal to z minus 1 upon 1. The second line was x plus 1 is equal to 2y is equal to minus 12z, or you can write it as x plus 1 upon 12 is equal to y upon 2y upon 12 will give you y upon 6 is equal to z upon minus 1. Okay, so now you can write it as A1 will be given by, for this A1 will be given by minus 2I plus K, and B1 will be 6I plus 6J plus K, and A2 will be given by, question number 109, the shortest distance between these two lines is given by what? Okay, the first line given to you is x is equal to y plus 2 is equal to, I'll take 6 common, z minus 1. This can be written as x, okay, this can be written as x minus 0 upon 1 is equal to y plus 2 upon 1 is equal to z minus 1 upon 1 by 6. Similarly, the second line is x plus 1 is equal to 2y is equal to minus 12z. And this can be written as x plus 1 upon 1 is equal to 2y upon 1. Okay, this can be written as y upon 1 by 2, and this is equal to z upon minus 1 by 12, right? So these two lines can be written in this form. Let's represent them in the vector form. The vector form of any line is given by r is equal to, r vector is equal to a vector plus lambda b vector. Here, what is a vector? A vector is the one through which the line is passing, and b vector is for the parallel line. All right. So here in this first equation of the line is, of course, see, line is passing through. Now this line is passing through 0, minus 2 and 1. Right? Because if you will put this is equal to 0, you will get x is equal to 0, you will get x, y is equal to minus 2 and z is equal to 1. Similarly, for this one, this line is passing through minus 1, 0, 0. Okay. Now, the parallel line. For this, see, the a vector will be given by minus 2j plus k. Let's say this is a1, and a2 vector for this will be given by minus I cap only. Fine. Now, direction ratios for this will be given by direction ratios will be equal to 1, 1 and 1 by 6. For this one, the direction ratios are 1, 1 by 2 minus 1 by 12. These are direction ratios. So therefore, the B vector in this case will be equal to I plus J plus 1 by 6K. Here, B2 vector, let's say this is B1. This is given by I plus 1 by 2J minus 1 by 12K. So here, R1 vector is given by A1, which is minus 2J cap plus K cap plus lambda I plus J plus 1 by 6K. Here, this factor is given by minus I cap plus mu I plus 1 by 2J minus 1 by 12K cap. All right. So now the shortest distance you have to find out between them. Shortest distance will be given by A2 minus A1 vector dot product with B1 cross B2 whole divided by the magnitude of B1 cross B2. Let's find out each and every term. So A2 minus A1, this is A2 was minus I cap minus A1 was equal to minus 2J plus K. This makes minus I plus 2J minus K cap. And the B1 cross B2, these two vectors will be given by I, J, and K. So 1, 1, 1 by 6. This is 1, 1 by 2 and minus 1 by 12. 1, 1 by 2 and minus 1 by 12. Correct? So this is I cap minus 1 by 12 minus 1 by 12 minus J cap minus 1 by 12 minus 1 by 6 plus K cap 1 by 2 minus 1. So this is equal to minus 1, 2 by 12. That is minus 1 by 6 I cap. This will be plus 1 by 4 J cap minus 1 by 2 K cap. I'll take 1 by 12 common from here. This will be minus 2I plus 3J minus 6K. So this is B1 cross B2 vector. Let's find out the magnitude of it. So B1 cross B2 will be given by root of minus 2 square plus 3 square minus 6 square, which is equal to 4 plus 9 plus 36. Or this is equal to root of 49. That is 7. Because there's a mod function outside it. So that's equal to 7. Right. See, one thing I forgot is 12. So this is equal to 7 upon 12. Okay. Yeah. So now let's fill in all the values in this given equation 1. From equation 1, I'll fill all the values. From equation 1, shortest distance will be given by, it was A2 minus A1 dot B1 cross B2 whole divided by mod of B1 cross B2 vector. So that is equal to minus I plus 2J minus K dot of 1 by 12. And this was equal to minus 2I plus 3J minus 6K whole divided by 7 upon 12. So you will be left with minus I plus 2J minus K dot minus 2I 3J minus 6K whole divided by 7. So let's find out a dot product. That's going to be minus 1 into minus 2. That is equal to 2. 2 into 3, 6. Minus 1 into minus 6 plus 6 upon 7. That is 14 by 7 or 2 is the answer. So we have option B as the correct answer. Hope you understood this question. Let's move to the next question for this paper now. That is going to be the last question, question number 110. That's the last mathematical question. The angle between these two lines is given by. Okay, so if I'm generally, I'm talking, if I'm having these two lines, the general equation for which is given by x minus x1 upon a1 is equal to y minus y1 upon b1 is equal to z minus z1 upon, sorry, here is a2 upon a2 is equal to z minus z1 upon a3. And the second line as x minus x2 upon b1 is equal to y minus y2 upon b2 is equal to z minus z2 upon b3. So these are the two lines. The angle between them, cos theta, is given by, please note down this formula. This is given by a1 b1 plus a2 b2 plus a3 b3 whole divided by the mod of, actually root of a1 square plus a2 square plus a3 square multiplied by root of b1 square plus b2 square plus b3 square. Now you have to fill in the values according to this question. So this is a1, a2, a3. This is b1, b2, b3. Let's fill in the values. So you will have a 2 into 2, a1, b1, 2 into 1 actually. 2 into 2. Sorry, this is 2 into 1, the a1, b1, right? This is 2 into 1 plus 2 into 2 plus minus 1 into 2 whole divided by root of a1 square. A1 is equal to 2. So 2 square is 4 plus a2 square, that is 4 plus minus 1 square, that is again 1 whole multiplied by 1 square 1 plus 2 square 4, 2 square 4. Okay, so here I have 2 plus 4 minus 2 divided by root of 9, that is 4 upon 9. That was equal to your cos theta. So theta is equal to cos inverse 4 by 9. This is the answer to the question. Cos inverse 4 by 9. This is option B. So option B is the correct answer to the question. Hope you have understood this. So with this question, students, we have completed all the mathematical questions of this paper. Hope you have understood them well and all your concepts were clear. A very best of luck for your exams, and don't forget to visit our website www.examsnet.com. It is a great site for you to practice your entrance exam question papers. You can also download our app. The link is available in the description box. So very best of luck. Keep shining, keep rising high. Bye.